to this channel. My name is Temitope Ojo. I'll be taking you through SD-WAN journey. SD-WAN stands for Software Defined Wide Area Network. And I'm sure by the end of this section, you will have confidence about SD-WAN. So let's go on. Let's kick in. Thank you. I'll be sharing my screen so that you can have the plans of our discussion today. Wow. We are starting. Okay. Hope you guys can see my screen. So discussion today will be talking about implementation of Cisco SD-WAN on IFNG or PNet. Funny enough, I'm using PNet. I'll be using PNet for this lot. So IFNG or PNet, that is implementation of Cisco SD-WAN. So we want to have but before we go into that, let's quickly look at the topology. This is the topology we'll be using for our lab. But before we really go into lab, for some people that they are just hearing SD-WAN for the first time, or they've heard about SD-WAN, but they've not really delved into it. They are looking up to maybe learning it one day. This is an opportunity for you to learn it. So quickly look at SD-WAN overview before we go into our lab. Let's go. Class objective. Today's class objective, we'll be looking at SD-WAN overview, certificate setup for Cisco SD-WAN controller, certificate setup for SD-WAN edges. Let's go in. Why SD-WAN? Before learning any technology, I always want to know the reason behind it. That is me, and I'm very sure that this applies to many of us too. We want one thing that always give us that drive. That always give us that drive before we learn any technologies, knowing what that technology, the reason why do I want to learn it? Let's quickly look at the reason why you want to learn SD-WAN or why you need to learn SD-WAN. SD-WAN is one good thing about it is that it has a separate control data plane and management plane, unlike traditional networks where all network reside on one device. So in traditional network, every of the planes, network plane, data plane, reside on one device. But when it comes to SD-WAN, it is quite different. It is not like that in SD-WAN. In SD-WAN, you have a data plane, control plane, and management plane completely separated. They are independent of each other. They could still be dependent, but they are independent in the sense that if there is a failure on the control plane, your data plane will still be working. If there's a failure on management plane, your control plane will still be working. Take for instance, in a traditional network, before we get to SD-WAN, in our normal our router or switches, on our router, we have a data plane, we have a control plane. On our router, we even have a management, we have management on our router. But you agree with me that if we have issue on the control plane, it will affect how the packet will be forwarded. And it will affect the management. So in most cases, we even lose management. We are not able to log into the device again because of an issue in one of the planes. But when it comes to SD-WAN, it's a solutions that help to resolve this. It makes things more easier and it makes troubleshooting very easy. And another reason why you love to want to learn SD-WAN is because when it comes to automations of your jobs, SD-WAN make it easy because with the help of the vManage, you can do a lot of automation. Your vManage will back up your config for you. It will back your config for you on it will back up the config of the vEdges and even the vSmarts. vEdges, vSmarts, vBond. It do configuration for all the edge devices in that infrastructure will be backup in the fabric. All the devices in the fabric, we have an automated backup. We will see this by the time we go in. Then another good advantage when it comes to SD-WAN is that we have an IPsec, an inbuilt SSL, and both SSL and IPsec connection where when it comes to SD-WAN. And one of the reasons why you want to use SD-WAN is SD-WAN helps with application recognition. When it comes to application recognition, it helps you to identify an application types, and you can actually specify which routes you want to use. For instance, you are using two different service provider. One is internet and the other one is MPLS. You can actually specify that, okay, on the MPLS, you want YouTube on the MPLS, and on the internet section, you want Facebook traffic to go through it. So it helps you to route traffic based on application. You know that would be very difficult in our normal traditional router. It will be very difficult for you to say, oh, you are doing you are doing YouTube on this, or you are doing internet on the other provider. But in this case, you can actually specify how you want your application to flow through. And even outside that, another thing it helps you to do is when it comes to this is it helps you with IPSLA. When it comes to your IPSLA, meeting your IPSLA requirement, you can define it for MPLS that once the SLA fails, once the SLA does not meet up with the 10 ms, then reroute the traffic via internet. The same thing you can do it too for any application. Let's say a cloud application you are visiting. Take for instance, you have an application on the cloud, and that's you can set SLA even based on that application, not only on your links. Now you can set SLA for that application that, okay, if I'm going to Google DNS, take for instance 888, and if this Google DNS fill an SLA that is doesn't if it doesn't meet up with SLA that is less than 10 ms, reroute the traffic. All these things you can define on SD-WAN, and that is the advantage that SD-WAN will give you. Then another advantage SD-WAN will give you is that it is very easy to deploy, and that is why we talk about zero touch provisioning, whereby when your V edges, when it comes to your V edges, you take your we call it X edges, and the reason why we call it X edges, it can either be V edge or C edge. The V edge means VIP teller edge, while the C edge means Cisco edge. These two, the V edge actually first came into the market because Cisco actually acquired VIP teller. VIP teller, they were doing basically focused on SD-WAN, and Cisco acquired it. And after Cisco acquired VIP teller, that's why most of the devices are named V edge. But with time, Cisco come into market to integrate their own native routers, the new routers, integrate new native routers, which they call enterprise and Cisco edge. So another advantage that SD-WAN would do for you, just like I told you, it's helps you to do an accurate load sharing. So you can use all your ISPs at the same time. So you can have more than two ISPs. I mean, you can have more than two ISPs, and make sure that you are using all of them simultaneously. So, and you can even determine the volume of traffic you want to use across all of them. So it has actually helped us to eliminate most cases whereby we will have more than two of the links. I will just be using one, and other links will be redundant. They will be redundant, will not be using. There will be a backup whereby you are not using them. So these are the advantages of SD-WAN. So let's go to SD-WAN architecture. For SD-WAN architecture, it's made up of 4 key components. These key components are SD-WAN manager, formerly we call it vManage, SD-WAN controller, formerly we call it vSmart, SD-WAN validator, formerly called vBond, and we have our WAN edge routers, known as the V edges. So we have the SD-WAN architecture. If you look at this diagram, the SD-WAN architectures, we have the orchestration plane, whereby you have your vBond, you have the management plane, where you have your vManage, we have the control planes, where you have your vSmart, then we have the data plane, where we have our physical WAN edges. So for the orchestration planes, okay, let's go. This is the architectures, and you can see before we go fully into explanation of each of the controllers in SD-WAN fabric, we'll quickly look at an important keyword there, which is DTLS. DTLS stands for Datagram Transport Layer Security. What is DTLS? DTLS provides encryption and integrity for your data packets transmitted over network, irrespective of your transport. Whether you are using Ethernet, you are using MPLS, irrespective of the transport you are using, what DTLS will make sure that it provides another overlay over that transport, which is DTLS, making sure that any data that's been transported over this transport is encrypted and integrity is in play. So this will prevent anything like eavesdropping or tampering with the packets. And it's also good. Another advantage DTLS will give us is because it's very good when it comes to low latency. It's quite very fast. And it is fast because it is using UDP, unreliable transport protocol. You know, when your packet is when you are using a UDP protocols, you know the advantage this gives when you are transporting your data. The advantage this gives is that there is no need for error correction. There is no need for retransmission. So these are the advantage that UDP offers, and because of this, DTLS is good to go because all our packets, they will focus on the speed. There's no need that we focus on the speed, which helps a majority of our applications that are where low latency and high performance are critical. Just like your voice, your video applications, DTLS, it allows for faster handshakes. It will reduce latency and make it suitable for a real-time application. DTLS is good to go, and that is why it is being used for in SD-WAN fabric. So another thing it helps you to do is, just like we said that we are using UDP, so that's helps you to handle your section resilience in terms of there's no need to undo packet loss, and it helps you to handle packet loss and reordering, which are common in UDP traffic. There will be no need for retransmission. There will be no need for error handling. Things are fast. So this is resilience when it comes to SD-WAN deployments, where network conditions are very important. Then authentication. Authentication is with DTLS supports mutual authentications. It ensures that both the client and server can verify each other identities. That is very critical when it comes to SD-WAN fabric, making sure that both clients, the server, meaning that both the controllers and the edges, we have authentications, whether between the controllers and the edges, they can identify each other. That need to prevent unauthorized access, because DTLS is a must. DTLS is a must before any of the device can be onboarded into the fabric. Before any of the device can be onboarded to the DTLS condition must be met. It must be met. That DTLS connection must be formed before any of them. The interoperability. DTLS is widely supported and can work with various applications and services. That it simplifies our management. By using DTLS, Cisco SD-WAN can simplify the management of secure connections across multiple sites, reducing the complexity associated with traditional VPNs. Let's dive in and look at the advantages, what these issues of this plane stand for, and what they are into. Let's look at Cisco vManage. vManage is responsible for your device management, policy, and network configuration. So you use your vManage for your configuration, to do your device management, to do your network configuration, and it has both GUI and CLI. But the GUI environment, you use it mostly because of it's very simple, it's easy to configure. It's GUI. I want something is GUI. You don't necessarily need to crown a lot of commands before you can make your changes. So, and it has a connection at the back end to the other controllers like the vSmart, vBond, and vManage with the help of SSL TLS. When their certificates have been validated, in this case, for controllers or for SD-WAN fabric, certificates are very important. Each device must agree on certificates. Each device must agree on certificates, and that is one inbuilt security when it comes to SD-WAN, is the certificates. And vManage only establish maybe one DTLS with X edges. No, if you have 10 X edges, 10 V edges or C edges in your network, so it means that you only have one DTL tunnel. You have one DTLS tunnel to each of the X edges. So I think we'll explain that further if you want to get to the practical. Then policy builds through the management plane. You can be distributed via vSmart, because you configure your policy on your vManage. And once those policies configure, it is being sent to vSmart via your network protocol. And once vSmart receive those policies, they help you to distribute it to your WAN edges using the OAP updates. So your vManage is always a virtual machine, and it can be hosted on-premise or in the cloud, or any of the cloud. It could be Cisco who can help you to host it. They can help you to host it themselves on their cloud, or if you want to audit or host it, if you want to host it on Amazon Cloud, that's AWS, or you want to host it on Azure Cloud, or you want to host it on Google Cloud, or any of the other vendor you can think of. So it's usually hosted, and it's usually a virtual machine, and it's to be hosted on-premise, maybe on any of your data center or the cloud environments. Wow, I hope you are following. This is just the GUI interface for Cisco SD-WAN, which we are going to see right now we start our practical. Then let's look at vSmart. Smart. It's a smart guy because it handles the control plane. And it is a virtual machine, just like the vSmart, that could be hosted on-prem or in the cloud. And it helps to distribute routes and policy informations via OMP. OMP means overlay management protocol. So, and how does that work? It works like a route reflectors. So it helps to reflect the routes from edge routers to each other. So all edge routers must pair with vSmart. Yes, because if you have edge router A connected to vSmart and edge router B is connected to vSmart, they will have to share their routes with the vSmart first. And the vSmart is the one that will reflect that route to the other peer. So that's how the OMP is more like the normal route reflector in our MPLS network, whereby the PE routers will pair with the alpha pair with the route reflector, and they will help you have to send the routes to the route reflector, whereby the route reflector will reflect to your PN. That's how the OMP works. This mask only permits VPN 0 and VPN 1 2. It means that you can only configure those two VPN. You can only configure VPN 0 and VPN 512 for on it. VPN 0 is your transport, while 512 is for management. If you try to configure other VPN, it will not take it. You will see that when we are doing the lab. vSmart establish more than one DTLS tunnel with XH, because you can have one edge router. Let's say you have an edge router in Lagos. I'm currently in Lagos, so I'll be using Lagos most cases when I'm referring. You have one edge router in Lagos connected to your controller, to your vSmart, and you have more than one transport. You are using, when I'm talking about transport, I'm talking about your providers. You have more than one provider connected to that VH. So in that case, let's say you have 3 providers. It means that you have 3 BTLS tunnels that will be connected to that router. If you have 4 providers, you have 4. Unlike vManage, on the vManage is only one BTLS tunnel that will be established. But when it comes to the vSmart, each as many transports you have, that is the number of the BTNS tunnels that is going to be established. So the overlay management protocol is used to exchange control information between the vSmart and all those. For you to exchange information, you actually need the overlay management between the vSmart and your edges. To check the VEdges that are connected to you to vSmart, you use show OMPPS. Show OMPPS. So just like in Cisco, iOS or XC or XR, whereby we use show IP, maybe OSPF neighbor, or show ISIS neighbor. But in this case, it's a show OMP PS. Then you will see all the PS. What those devices that are pairing with your vSmart here, they are your VEdges. They have connection with other controllers, but the PS now, when you need OMPs, the overlay management protocol is between the vSmarts and the VEdges. That is where you use the OMP. You don't use OMP within the controllers. You use it between the vSmarts and the VEdges. Okay, the next controller we'll be talking about is Cisco vBond. Cisco vBond is for orchestration plane and is primarily used for authentication and authorization of X edges. So basically, you use it to authenticate and authorize your edges. That is your edges and other controllers, please. And other controllers. So vBond is always the first point of authentication for all devices in SD-WAN architecture. So basically, for any device to be integrated into SD-WAN fabric, they must first go through the vBond to have that authentication done. And once they are being authenticated by vBond, because vBond must know about their serial number. And once vBond knows about those serial number, whitelist them. We call it whitelisting. Once that they are whitelisted, then they will be the DTLS tunnel will be up. So X edges creates what we call a first establish a temporary DTLS to vBond for you to see what is going on with establishment with other controllers or edges. You just say show orchestration connections. Then Cisco WAN edges. That's the last thing we'll be talking about in SD-WAN fabric. Cisco edges, just as the name implies, this is the device where customer connects their WAN network. I've been talking about the transport network. The transport network, I'm using MPLS, I'm using Ethernet, I'm using 5G network, I'm using 4G network. Any transport you can think of, or any service provider that is giving this, they are terminated on Cisco edges. They are terminated on Cisco edges. So it is always located at the site. So it could be called as CP in a traditional network. We can refer it to CP in a traditional network, and we can still refer it to PE because that is where your data service are. That is where you configure your data service, just like your VRF. That is where they are being configured. That's your service VPN. That is where your service VPN is going to be configured. So if we are saying, though, that is where our service VPN will be configured, then it's acting like a PE. But that if you are saying, oh, that is the point where your customer will be connected, then it's acting like your customer premise equipment. So it's in between, it's serving both role anyway. However, let's go into it. It's always located at the site. It could be hardware and software, but most cases an hardware device, and it can either be VH or CH. The VH is inherited from the Viptela Cisco proprietary hardware. Cisco acquired Viptela. After they acquired Viptela, they call these devices V edges, that is Viptela edges. And C edges, they are the Cisco devices. The Cisco devices that supports SD-WANs are ISR1K, ISR4K, ASR1K, and Catalyst 8K. Those are the Cisco devices. That's a C edges that supports SD-WAN. And it supports this V edges, C edges. They support transport management and service VPN. Other controllers we've discussed about, they only support transport and management. They don't support service VPN. If you try to configure, when we get to configuration, you will see it. If you try to put your configuration, it's going to reject it when it comes to service VPN. Anything outside VLAN 0 and 5.2, it can be configured. But for your controllers, you can configure, it's on it that you can even configure your service VPN. So service VPN 1 to 511 and 513 to 65,528. Those are the VPNs that are the range of VPN that are supported on our X edges. So all controllers must have the serial numbers of the X edges. That is the whitelisting we talk about when we're talking about VBond. So all the controllers must know about the serial number, about the serial number of the X edges. That is whitelisting. And once whitelisting is done, your DTNS will come up. Then IPsec tunnels are established between edges only. So it's only between the edges. I have an edge in Port Harcourt. I have one in Lagos. I have an edge in Ghana. I have one in Nigeria. They talk to each other on IPsec tunnel. So those guys, they only talk to each other on IPsec tunnel. Once they want to send their service VPN, it runs only on IPsec tunnels. So once this tunnel are established, even if all the controllers are down, in this case, once the tunnels are up, service VPN are transported. Even if controllers are down, VBond gone, vSmart gone, vManage gone, your services will still be up. X edges will be able to pass traffic because data plane is up, except you want to, any of them goes down and try to come up again. That's where there will be an issue. But once all the edges are up, they can, because all of them, all the edges, they are running on the transport, they are running on the transport. What I mean by transport, they are running on your 4G, on your 5G, on your internet. So except those transport goes down, let's say I have to transport to my edge in Lagos. I have MPLS and internet. If those two transports goes down, that is when Lagos will be isolated. But provided that one of those transporters still up, I can communicate with every other edges. That is what is key. So whether any controllers goes down, communications goes on. Except you want to advertise a new prefix or you are adding a new VRF. Thank you. This is where we'll stop. We'll move on to our configuration in the next class. Thank you.